Hello students, welcome to LJ Institute of Engineering and Technology. Here myself Mr. Jaiswal Kishan, Civil Engineering Department, and here we are learning all about structural analysis. So today we are in session number 6, and in today's session we will be learning one more example of beam, but today we will be learning a part of sinking kind of a beam. So let's see. So today we are taking a sum with sinking. Till date we were doing sum on without sinking. So today we will be starting sum with sinking. Now here example, analyze the beam by slope deflection method if support B sinks by 5 mm and support C sinks by 2 mm. Means here there are two supports which are sinking. One is support B and another is support C. Now here you can see that this is a B support and this is a C support. Now here E and I also value is given. E value is given 2 cross 10 raised to 5 Newton per mm square and I equals to 16 cross 10 raised to 6 mm raised to 4. Now draw bending moment diagram. Now here you can see there is a 3 span beam, A to B, B to C and C to D. On AB span UDL is given, on BC span concentrated central point load is given, and on CD span 10 kN eccentric load is given. So let's start our example. Now as basic our first step will be fixed end moment, but before that we will be carry out this sinking effect. Now here you can see, now how to solve this sinking, let's understand. Please be focused. Let's see here A, B span I have taken out. Now in the question it is given that B is sinking by 5 mm. So I have converted in meter, which is nothing but 0.005. Now A to B, in which B is only sinking, A is not sinking. So AB span total deflection, that is sinking, will be 0.005. Now for BC span, both B support as well as C support is sinking. Now B support is sinking 5 mm, C support is sinking 2 mm. So I have converted into meter, which is 0.005 and C is 0.002. Now we have to take an net effect of this delta. Means look, this is sinking 0.005 and this is sinking 0.002. So B is sinking 0.003 more than C, so we have to take it as a net effect of the entire span BC. If both the support are sinking, then we have to take a net effect, means 0.005 minus 0.002 means 0.003, B is sinking. Now for CD span, and for CD span only C support is sinking, which is 0.002 means 2 mm. Now look here, I have written positive, negative, negative. Now what is this positive and negative? Now when you see AB span in which A is not sinking but B is sinking, so B is sinking in a clockwise direction. So in the starting of this series of chapters we have discussed that positive will be clockwise. So there it is positive which is going clockwise, so we have to take it as a positive. Now this BC span in which B is sinking more, so if you stand at C and you can look at B that it is sinking downward, which is in anti-clockwise direction, so it should be negative. Similarly for CD span, D is not sinking, C is sinking, but it is sinking downward. So from D where it is 0, we have to stand over there and see it is going anti-clockwise direction, so negative. Now this was the effect of sinking. Now how to use, we will see it in step number 2. Let's start with our step number 1, which is nothing but fixed end moment. Now in fixed end moment, our first is UDL, second is point load, and third is our eccentric point load. Now for UDL we have learned formula that it is minus WL square by 12. So W is 10, length is 4, so 16 divided by 12 will be getting minus 13.33. Similarly MFBA will be plus 13.33. Now for point load it is WL by 8, for MFBC it is negative, for MFCB it should be positive. So we kept formula 20 as a load, 4 as a distance, divide by 8 as a formula, we will be getting minus 10. Similarly here, plus 10. Now for eccentric load, here we have to find which is A. Now 1 meter is my A, small a distance, and 3 meter is my small b distance. So the formula for MFCD will be minus WA B square upon L square. W is nothing but my 10 kilonewton. A we have considered as 1. B we have considered as 3. So 1 and 3 square is nothing but 9. Divide by total entire length span, means 4 meter is 16. 4 square is 16. So I will be getting minus 5.63. I would like to repeat it again that don't keep it as plus 5.63 because there is a difference in formula. Here it is b square, here it is a square. So till here we are doing same value, but here you can't keep same value as it is. Now for MFDC we have to calculate W a square b by L square equals to 10 into 1 is my 1 square equals to 1 only. 3 divided by 4 square 16 will be getting 1.88 kilonewton into meter. So this was our first step, fixed end moment. Now our second step is slope deflection equation. Let's see. Now for MEB formula which we did in earlier, MFAB plus 2EI upon L into bracket 2 theta A plus theta B minus 3 delta by L. Now you remember this formula, and also you remember that till date we were keeping delta as a 0, but now we have to keep delta its own value. So I will be explaining how to keep delta value and what amount. Now let's understand. MFAB which we have calculated in step number 1, which is minus 13.33. Now here I and I, only single unit I is given, so we will be keeping 1 EI upon L of AB span is 4 meter. So till here we have just placed a value. Now theta F. Now look here, it is a fixed support, so it's not an unknown. Our unknown is only B and C. So at the place of theta I will be keeping 0 plus 1 theta B because it's my unknown minus 3 delta upon L. Till date we were keeping delta as a 0, but now we have to keep delta its own value. Now for AB span, here you can see how much delta was coming, 0.005, which was in positive. So keep 3 into 0.005 as a positive value, delta divided by 4. Now solve this entire minus 13.33 as it is. 2 by 4 is nothing but 0.5. Now here I have multiplied with 1 theta B, so I will be getting 0.5 EI theta B. Now the entire thing has to be multiplied with this, so I will be getting 0.0019 into EI. Similarly for MBA we have to keep theta B as unknown and delta as a value. Now what delta value has to be kept? Now for AB which we have put, similarly for BA we have to put, means this 0.005. Look. So after solving this, we will be getting 13.33 plus 1 EI theta B, because as per formula now it will be 2. So 2 multiplied by 0.5 will be 1 minus 0.0019 EI as it is. So this was our step number 2, first part. Now next we have to do for BC span and for CD span as well. Now for BC span we have to see what is the value of delta. So for BC span it is 0.003 and for CD span it is 0.002. So at the place of BC span we have to keep 0.003 but in a negative form, because it is anti-clockwise, so we have to keep it as a negative. Look, here I have kept as a negative. Let's understand. MBC is nothing but MFBC plus 2EI upon L into bracket 2 theta B plus 1 theta C minus 3 delta by L. MFBC which we have calculated in step number 1, which was minus 10. So placed at a minus 10 plus 2 upon 4. We have seen that it is only single unit EI. So 1 EI multiplied by here both B and C are my unknown. So 2 theta B plus 1 theta C minus 3 into delta will be minus. Why minus? Because it is going anti-clockwise direction. divided by 4. L is my 4. So minus 10 as it is. 2 by 4 is 0.5. Multiply by 2, I'll be getting 1 EA theta B. 2 by 4 0.5 into 1 equals to 0.5 EA theta C. 3 by 4 multiply by minus 0.003 multiply by 0.5, I will be getting minus 0.001. So here you can see, here it is a minus, so value will be coming in minus. So minus minus, it will be plus. I will be solving it for the equation. So I have kept it as a minus only. Now for MCB, it is similar to like MBC, but in the place of 1 theta c it will be 2 theta c, and at the place of 2 theta b it will be 1 theta b. It is just a formula. So by placing that, I will be getting my equation number 4. Now for CD span, we have seen that it is value 0.002 in negative, so we will be placing it in for the equation. So MCD is nothing but MFCD plus 2EI upon M in bracket 2 theta C plus 1 theta D. Now here theta D will be 0 because it is my fixed support, and fixed support is not my unknown. Minus 3 delta by. At the place of delta, I will be keeping minus 0.002. So like this, after solving, I will be getting my equation number 5 and equation number 6. Now, moving ahead, our next step is equilibrium equation. Now, equilibrium equation says that summation of moment at a primary unknown should be equal to 0. So our primary unknown is at B and second primary number of unknown is at C. So at B, MBA plus MBC equals to 0, which is my equation number A. At C point, MCB plus MCD equals to 0, which is my equation number B. Now let's see what is equation A. In equation A, we have to combine MBA, which is my equation number 2, plus MBC, which is my equation number 3. So I've just placed equation number 2 and equation number 3. Now, this is theta B, 1 plus 1, 2EA theta B. There is only single theta C, so I have kept as it is. Remaining, all the EI value of delta I have summed up over here. And this constant 13 minus 10 is nothing but 3, and placing it opposite of equals to, so it is minus 3.3. So this I will be getting equation A. Nothing I did, just a algebraic sum of MBA plus MBC. Similarly, we have to do for MCB plus MCD. So this is my equation number 4 and this is my equation number 5. Look. We have did equation number 4 MCB 10 plus 0.5 A theta B plus 1 theta C minus 0.001 EI. This minus minus equals to 1. I have took it in a calculation. I will show you. And this is equation number 4. After solving this, I will be getting my equation number B. So 0.5 A theta B plus 2EA theta C, because it is 1 theta C over here, also here 1 EI theta C is given. Now EI, this one and this one I have summed up and kept over here, and plus 10 and minus 5.63 will be giving on the equals to opposite side, which will be minus 4.38. So this is my equation B. So equation A and equation B, if we solve, then we will be getting our both unknown value, which is nothing but theta C and theta B. Look, this is my equation A, this is my equation B. I have multiplied this 0.5 with equation A and this 2 with equation number B. This is not but an elimination method which we have learned in maths. So after multiplying this, I will be getting this 2 more equation. This will be cancelled out. By solving this, it will be getting minus 3.8 EA theta C. Here it will be cancelled out because here minus minus plus. As I said, I will be solving it again in for ahead. So this minus minus plus and this will be directly cancelled out. I will be getting 0.20.3. So theta C is nothing but my minus 5.4 upon EI. So after multiplication of this 2 with these 2 equation, I will be getting this 2 more equation, After solving this with an elimination method, which we did in maths, simple calculation, we will be finding out value of theta c. Now, place this theta c in any one of the equation A or equation B to get theta b. Here I have placed it in equation A. So, I will be getting the value of theta b as well. So, after getting my both the value of theta b and theta c, place it in the step number 2 slope deflection equation to get the further final moments, which we did in earlier sums. So, final moments will be MAB equals to minus 18, MBA equals to 8.2, MBC equals to minus 8.2, MCB equals to 8.6, MCD equals to minus 8.6, and MDC equals to 1.5. We have discussed earlier that summation of moment this should be 0, so it is coming nearly 0. Similarly at C, both the algebraic sum of these two moments coming 0. Now for diagram, as you know, negative will be up, then 8.2 positive up. If I see from BC span, it is negative, so up. From BC span, if I see right side, so value is coming 8.6, so up, and then minus 8.6 for CD span. So if I am taking left side, so it should be up, and this 1.5 right side up. And after joining this, I will be getting end span moment. For center span moment, we have formula for AB, which is UDL, so WL square by 8, which will be getting 20. So it will be curve. Why curve? Because for UDL we have to keep it as a curve, and for concentrated load or a central point load, we have to keep where the maximum load occurs. Means wherever the load, there the point of maximum bending moment will occur. So for central point load, the formula is WL by 4, and for eccentric point load, the formula is WAB by L. So this we are diagram of bending moment. So let's have a quick revision. We did fixed end moment, we have calculated slope deflection equation, applied equilibrium equation, then final moments with the help of step number 2 and 3, and then draw shear force and bending moment diagram. But here it is only asked bending moment diagram, so we have drawn only bending moment diagram. Whatever asked, we have to draw that only. Now here the only change is delta is given, means sinking is given. So the only change till we have done the same sums in which the sinking was not there, but here sinking was given, so we have just solved this sinking value and placed its delta value in the respective format. If it is clockwise, so positive; if it is anti-clockwise, so negative. Then we have find out this equilibrium equation, then final moment and its bending moment diagram.